Right. I like it when I have to unhide a whole lot of people. Even though it takes time, I know we're going to have an exciting show. So this is all good news. Well, hey, everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, January 9th, 2015. So we got a bunch of our regular kinds of stories today. We're going to be talking about the SpaceX delay, super oceans on super Earths, how to see Comet Lovejoy, all kinds of crazy new exoplanets, new images of Andromeda, all kinds of great stories. But we've also got a very special guest this week. So I'm going to introduce him right now, and then we'll move on as well. So our special guest this week is Andy Weir, author of The Martian, which I am about to go on and on and on about. But Andy, welcome to the Weekly Space Hangout.
Thanks for having me.
And then we've got Dr. Brian Koberlein.
Hi.
We've got David, not quite traveling Dickinson, somewhere in Maine.
Hey, staying warm up here in northern Maine.
We got Morgan Rehnberg. Hey, Morgan.
Hey, Fraser.
And we got Ramin Skibba, back from the AAS, and boy, is his arms tired.
That's right. Happy to be back.
Awesome. All right, so as I said, we got a bunch of space stories, but we're going to spend probably the first half of this show talking with Andy Weir, which, again, I'm super excited. I apologize if I just mumble a lot and every now and just gaze into the camera. It's because we're talking to Andy Weir. But you can talk to Andy and everyone else if you wish. And the way you can do that is you can ask questions using the Q&A app. So if you go to, right now it'll say you're watching this video, it'll say Fraser Cain is interacting with you. You can ask your questions there, and you can see all the questions that people have asked. So I will start with a whole bunch of questions for Andy Weir, and then we'll go from there. So Andy,
Yes.
so can you give people, I guess, a bit of a background of this book that you wrote, and sort of people haven't even read The Martian and have no idea who this person is that we're talking to. Let's start there. What is The Martian? What did you do?
The Martian is a book about an astronaut who gets stranded on Mars. His crew think that he's dead because there was a sandstorm, and they had really good reason to believe he was dead, and they had to do an emergency evacuation. So off they go. He's not dead. He survives, and he's on his own, stranded on Mars, and nobody knows he's still alive, and he has no way to communicate with Earth. So that's the setup, and it's about his attempts to stay alive on the planet by himself.
And this book, which I think has been making a bit of a phenomenon in the space fan community, you actually have been working on this book for a long time. You had written this book in a fairly unconventional way and even tried to release it, right? Can you tell us a bit about the story about that?
Yeah, sure. Originally, I wrote the book. So I've been writing fiction, serials, and short stories on my website for over 10 years, and it was just one of the things that I was posting to my site. I released it in serial form, just one chapter at a time, posting it to my website, and I never imagined that it would become a book, let alone a movie or anything like that. When I was done, I thought, okay, I'm done, moving on to my next thing, and people started emailing me saying, like, well, hold on, I like this story, but I hate reading it in a web browser. Can you make an ebook format? So I did that, and then I got emails from other people saying, like, well, okay, thanks for making an EPUB or format, but I'm not really technically savvy, and I don't know how to download a file from the internet and put it on my Kindle. Can you just put it up on Kindle? So I figured out how to do that, and it's pretty simple, but Amazon won't let you post things for free, so you had to charge at least 99 cents. So I said, like, okay, here you go. For 99 cents, you can buy it from Amazon, or you can download it from my site for free. And more people bought it from Amazon than downloaded it for free, just because the convenience of just like, yeah, I'll pay $1 and then I can push a button and it's on my system. And it got up into the top sellers list, and it got around through word of mouth like that. And then Random House came and said, oh, we want to make a print edition.
I'd like you to. I don't understand this electronic version. I'd like you to kill a tree, and and paste the words on the tree. Could you do that?
Well, I was happy to have them kill trees and paste words on them, because that's been a dream of mine my whole life. So.
And so to give people some context, and there's even more exciting news which we'll get to in a second, but can you give people context, like how many copies are out there now, if you're at liberty to discuss?
Yeah, I can talk about it. Between ebook and print, total, I think they've sold about 380,000 copies. And I think about half of those are print and half of them are ebook, roughly.
And so the more exciting news is that this has been picked up for potential movie, right?
Well, not just potential movie, they're filming it. I mean, they're filming it right now. So, yeah, it's directed by Ridley Scott, starring Matt Damon as the main character. It's also got, let's see, Sean Bean, Kate Mara, Chiwetel Ejiofor, Donald Glover, a bunch of people. I'm just forgetting. Kristen Wiig. Yeah, Jessica Chastain, yeah. Kristen Wiig, Sebastian Stan.
Is there a set release date?
Yeah, November 25th.
Awesome.
It's the day before Thanksgiving.
2015?
Yeah. This
Wow.
year. Well, they started filming it.
That's fast.
They started filming it in November of last year. So they've been working on it for a while.
Go see the new Star Wars and go see that.
Yeah.
Yeah, we come out 3 weeks before Star Wars, thankfully. So it doesn't have to open against Star Wars or anything.
So now I consumed your book via Audible, listened to the audiobook, which is just they did a terrific job.
The voice actor is named R.C. Bray, and he's a great narrator.
Yeah, and he did great both the individual characters, both the main character, but also all of great individual voices for each one of the characters. So literally, the person just talks, and you know who's talking, and he's having these crazy conversations with someone with a with a European accent, somebody with an American accent, someone with a Southern accent, women, and he's able to sort of do all these different voices all at the same time, and it really gives context. I, of course, I read the book 10 hours, it takes 10 hours to listen to. It took me 10 hours to listen to it, like consecutive time. I listened to it with my son, my 10-year-old son, and he gobbled it up in one bite. I had my dad listen to it. He listened to it. He's like, I couldn't stop listening to it. My girlfriend couldn't stop listening to it. There is not a single person who I have exposed this book to who hasn't been unable to put it down. And so, I say this to all the book authors, all the space book authors who come to the Weekly Space Hangout, but this is by far the most entertaining book I have read easily in the last year, easily in the last decade. Like, if you have not read The Martian, you have, tell you what, we'll wait right here for 10 hours for you all to go. Yeah, start the clock. You go read the book. We'll be here, and then come back, and then we can all talk about it. It is that good of a book, and I say that because it is a dense, technical, math-oriented. Like, if you want to know how many potatoes can grow on Mars in a habitat, Andy's done the math for you. So why did you go to such detail and how did you pull that off?
Well, so I've always been a space nerd, and into the I get really into the technical details of the space programs around the world, and I pay a lot of attention, and I'm kind of fairly. I mean, it's not my profession or anything, but I'm fairly well educated on all that stuff. And whenever I'm reading science fiction, it always bugs me when I see something that's really inaccurate. And I'm like, it sets off this little flag in my head and kind of ruins my suspension of disbelief a little bit. So I wanted my book to be as realistic as possible. Remember when I was writing it for I had a few thousand regular readers on my website. I was writing it for them, who were all like nerdy, geeky, technically minded people like me. So I'm like, oh yeah, I can go hog wild on the math, and my readers will love it. I had no idea it would have broad appeal. If you'd asked me, I would have said, well, no, it's basically. It's basically like a technical treatise. I didn't imagine anybody would like it outside of that tiny core group. So.
And for your, for the book publisher, and I think this is sort of the magic to the story. Part of why I love it so much is that they couldn't come in and wreck it and tell you what you could and couldn't write, because you had already written it and it was already incredibly successful. And this same phenomenon where a person's like, Andy is flinging numbers at me, and it's just the best thing I could read.
Thanks. Yeah, there was an editing process though, but they didn't have any problem with the technical aspects or the length of explanations. In fact, they asked me to expand on a few things, where the editor was like, "Well, I don't think everybody would understand this part. Could you explain it in a little more detail?"
Yeah.
Mostly, it was just kind of like, uh, I'm not a very good writer. I have a tough time like writing good prose, like making the words be nicely readable. You know what I mean? And so there's areas where the editor's like, okay, this is really clumsy, and this is like, and here you have a scene with two people talking, and you never told us where they are, and stuff like that. That was the sort of edits that we did.
And so having that editorial process really did help you tighten
Oh,
everything.
absolutely.
Yeah.
Oh, it's a much better book thanks to that process.
So I guess my next question then is what in sort of communicating this story of Mars, like you went through all of this personal research. I know that you wrote computer simulations for the kinds of missions, the kinds of orbital trajectories. Did you just whip this up in Kerbal Space Program? What did you do to understand the underlying science?
Well, so I had to do tons and tons of research, of course. I'm a computer programmer by trade. That's what I did for a living up until April of last year when I quit to go full-time on the writing. But 25 years I've been a computer programmer, so I try to use that to solve problems. And I wanted it to be accurate on the orbital trajectories they took to get to and from Mars, but their ship constantly accelerates. So it's not just like it's not like one of the Mars probes that we've sent in real life where it has like a point thrust acceleration at Earth. Let me get on the camera. Point thrust acceleration on Earth, then goes goes just ballistically to Mars, and then another point thrust to insert into Mars orbit. No, their ship Hermes is constantly accelerating due to ion engines, so it would make this spiral around the sun like not an orbital trace. And the math to figure that out was well beyond me. And so I went online and said, well, how does NASA work this stuff out? And they do it with simulation. So I made my own simulation, a little solar system thing showing the planets moving around, and then the orbital trace, and then I could adjust it here and there until I finally found the path. Yep.
Oh, and I mean that's one part of it, but I mean there is like calculating potato yields. And,
oh yeah,
that
was just a bunch of math.
Yeah.
That's fun. Well, it's fun for me, and so I actually I enjoyed doing that stuff. I'm like, ooh, okay, how much surface area does he have to grow with? Okay, what's the yield of potatoes, and work from there.
And so I guess with all this stuff, and I guess and so the other part to that's really kind of amazing is the solutions that he comes up with to survive the stuff that happens, because like just on its own Mars is a very hostile place and it really wants you dead, but in addition to just not dying, he has to deal with a whole bunch of really awful things. And there's one part in the book where I'm like, there's no way, like this is when the Martians come and they take care of him, because there's no way he's getting out of this. And I don't want to spoil the book, but there is a part where seriously, when he starts to break into this, you're like, that's it. He's done. How did you deal with these ideas?
Well, I would come up with the problems. So first I'd come up with the problems. I'd be like, all right, so here's the situation. What is the next thing? What's the thing that's most likely to go wrong? I tried to make each problem be, kind of flow from the solution to the previous problem. So the whole book is just one big long cascade failure, right? Like this failed, so he had to do that. So that caused this to fail, so he had to do that, and so on. And then I would sit there and I'd say, like, okay, how does he get around this problem? How does he get around this problem? How does he fix it? And if I couldn't find a solution, I'd be like, well, he's not going to have that problem. And then, or sometimes I'd be like, oh, he could solve it if he just had this one fairly reasonable thing. Like if he had this one device or something like that, that then I go back and over the previous like 7 chapters mention that he's had that all along. And then to the reader, it doesn't seem like, bull crap.
Problem solved.
Problem solved.
Right. And so, I can imagine, like, I can think about, like, for example, the potatoes. Like, you had to come up with a rationale for why he
had a live potato. Right.
Yeah.
Like why he had a viable potato that could germinate. It's hard to explain why he had one of those on Mars.
Right. I would have loved the situations. I don't know. It's like simulation after simulation where he dies, and you're like, well, I can't. I got nothing.
No,
And
that one didn't work.
I can choose you on adventure.
yeah. Just
Well, almost, but it was like it wasn't based on decisions. I was like, here's a thing that could break or go wrong, and then I think about it for like 3 days, and I'm like, no, he'd die. There's no way out of that.
And he was stranded with disco too. I mean,
Yes. Poor guy. Stuck with,
it was kind of a nifty little touch.
Well, that's the other part, right? Is that the having a character who is, I guess, that positive and that resilient.
Mhm.
Did that when you sort of decided on the character, did a lot of thinking go into that? Because Mark Watney is a very special human being.
Well, so I didn't want it to be like this dark story about a man's descent into loneliness and insanity, right? I mean, it could have been a really dark and sad and depressing story, but I really wanted to focus on the MacGyver-y solutions and stuff like that. And so I just said, like, yeah, a normal person under that constant stress and complete isolation would probably crack, but this guy was chosen to be an astronaut to go to Mars. He's sort of a cut above a normal person. He's not just like some guy who like survived a commuter plane crash. He was picked specifically because of his strength and resolve, and so I just decided I could hand wave everything away by just saying that.
Yeah, and then by having the training that Watney has, he's good at mechanics. He's also a botanist.
Mm-hmm.
These were sort of the two, the two skills that were going to keep him alive, right?
Yeah, and these are reasonable skills for, and astronauts are extremely well trained, right? So it's okay and expected by the reader for him to be super competent.
Yeah. All right, I got a couple of questions I'm going to ask from the audience here. You may be surprised, people are watching. So Cecil Morgan asks, how well did the scriptwriters do translating a detailed technical book into a general audience movie format? And this is absolutely one of my top questions. I'm sure you've read the script. I hope you've read the script.
Yes. Yeah.
I hope you got script approval of some variety.
No script approval. So my only job on the movie is to cash the check, pretty much. But they do talk to me about stuff just because they're interested in my opinion, and they keep me up to date on what's going on just to be cool. Drew Goddard wrote the script. He wrote Cloverfield. He directed Cabin in the Woods. So he wrote the screenplay for it, and I think he did a great job. I think it's a good adaptation of the book. Of course, if you were to make it's like any other book to movie adaptation. If you were to show everything that happened in the book, then the movie would be like 7 hours long, right?
Right.
So stuff had to be cut.
Math coming up in the sidebars.
Right. Yeah. Well, also just the number of events that happen in a book is much longer, much more than can usually be shown in 2 hours, right? So, I mean, some stuff did have to get cut, but I think they did a good job on what they cut. I think he picked the right stuff. If it had been up to me, I would have picked the same things. And it's really true to the book. So that's about all I can say. I can't give too much in details because the studio doesn't like it if you give out too much info.
Yeah.
I'm happy with the screenplay though.
Yeah, I mean, I think that when people have followed media, like I don't know if anyone's ever seen the comic book adaptation of The Dark Knight Returns, and there's the cartoon version of it, and it's really just a screen for screen adaptation of the comic book done as animation. It works great. That I hope that the lesson that people are starting to learn, especially with Game of Thrones, is that trust the author. They did a good job. They put their thoughts together in a proper direction. The character, it's okay. It's not too complex. People can handle it. And so that's all I really am hoping for, is that the people who work on the movie have respect for the intelligence that you assume the people who are watching and reading have.
Yeah, and I think they're doing that. I mean, also bear in mind, for like a TV show, it's different because you have sort of an infinite canvas. Like Game of Thrones spends literally 10 hours per book.
Yeah.
Right. You can. It's 10-hour-long episodes. They've got as much canvas as they want. But yeah, I'm really excited by it. Like one thing they do care, they care a lot in this production about the scientific accuracy. That's something that's really important to Ridley. And he was I would get these questions occasionally that got filtered through like 7 layers of indirection. Like I've never spoken to Ridley Scott, but I'd get these questions and I'd say something like that, and he'd be like, "Hey, that sandstorm wouldn't really have enough momentum to do a lot of damage, would it?" And that's one of the things, and that was a concession I made in the book to reality. Like in real life, a Martian dust storm would not, like the wind, even 150-kilometer-an-hour wind on Mars wouldn't knock stuff over or be a threat because the atmospheric pressure is so low that the total inertia is really low. And that was like a question that came through from Ridley Scott. He's like, "Well, wait, what about that?" And I'm like, "Yeah, that was a concession." And he's like, "Okay, well." Yeah, we'll work around it. But it's nice to see them care that much about the technical accuracy. It's cool.
Okay, his question comes from Thomas Traniker. Oh, that's the wrong one. But his question was, how long have you been cooking this book in your mind?
Well, in my mind, I started working on it. I mean, I started coming up with ideas for it a long time ago, probably around 2003 or 4. I first started posting chapters in 2009 and finished in 2012. So it took me about 3 years to write, and it was kind of percolating in the back of my head for, I don't know, years and years.
Yeah. What are you working on now?
Right now, I'm working on. I've got another book deal with Random House for a book called Zhek, Z-H-E-K. I had posted a bunch of chapters to my website around this. I was working on it kind of at the same time as Martian. Now that Random House owns the rights, the chapters are no longer posted on my website. But I'm working on that. It's less of a technically rigid, accurate sci-fi, and it's more like traditional. It's like got aliens and faster than light travel and telepathy and stuff like that.
I want to see the math.
You want to see the math? There is some math. There's some math. I've got some concessions to reality so that I can have the cool stuff I want. Everything else is all physics.
So we should be seeing trailers to The Martian like really soon in the theaters.
Well, I don't know. I asked them about that actually, and I'm like, hey, because that's the next most exciting thing for me. Is like, ooh, So the first thing, the first interesting thing that'll happen is we'll see the movie poster, or actually we'll see I think it's called a one page, or I think it's called a one page, which is sort of the early version of the movie poster that they use until the real marketing push starts, and they should be working on that pretty soon. I don't know when they're planning to make a trailer. I mean, they've got scenes in the can, so they actually have like footage that they could use for a trailer. But of course, there's going to be a bunch of CGI that they need to finish before they can show that. I honestly don't know. And I don't know if they know. I don't know if they've decided when they want to show a trailer.
Comic-Con?
Yeah, usually.
Let's see. Comic-Con is July. Is that right? Is that
Labor Day? There's a lot of.
I'm talking San Diego Comic-Con.
Yeah, August.
July or August?
Yeah.
I'm not an expert, but I'm guessing they would have had a trailer out before then, because it's like August, September, October, November. That's only like 4 months before the release, right? 5? Yeah, maybe. That might be a good place to debut. I'm not sure.
Hey, there's Dr. Nicole Gugliucci.
Hi, sorry I was in meetings.
That's all right. You're doing the real science here. Well, we're just talking about it. Made up stories about science. Nicole,
stories that I absolutely need to read, because I haven't read your book yet, and everyone has been recommending it to me and saying it's wonderful. So, yay.
Well, I hope you like it.
Those people are right. I think I was one of those people.
You probably are.
So Guido Bibra asks, is there any kind of sequel planned?
No, it's not really a sequelable book. Any sort of attempt to make a sequel would really strain plausibility. I mean, I don't want to give spoilers to the ending, but those of you who've read it, you think about how the book ends, and then you're like, okay, where do you go from there that isn't completely silly?
Now that's just quitter talk.
It's just
for Die Hard. Yeah, come on.
Well, so that's a different, like, in a realistic scenario, like for an action movie star or something, or a detective novel or whatever, it makes sense for the main character to just keep getting in trouble again and again for sequel after sequel, because you just take that as like, oh, okay, Bruce Willis's character in Die Hard, he lives in a universe where he's an action hero, and so that sort of trouble just follows him around. You just accept it. But I went to so much effort to make everything be technically accurate and everything be plausible that now the reader would be like, I don't know about this. I'm not buying this happening again.
Well, you can still play in the same universe, maybe,
Right,
but
yeah.
with further down the road with the Martian colony and maybe have a cameo, but.
But then that's unsatisfying to a reader, right? It's like, oh, I love this character, and he's like a really minor cameo in the so-called sequel.
Right.
You don't like that,
yeah,
right?
I think we need to go back to it's just you can't believe it. What were the chances? Here
What
we
are the
are
odds?
again. What were
Can't
the
get
odds?
a break.
You can't get a break. So now a lot of the technology that you used, stuff like the Mars ascent vehicle, Mars descent vehicle, the kinds of rovers, the way you had planned out this mission, parts of it seemed the kinds of stuff that Bob Zubrin has been screaming about for decades, but parts of it seemed like you had done some original thinking about how some of these missions might get planned out. What are some of the sort of the ideas that you sort of added to the gun?
Right. Well, I think Mars Direct is a little out of date now. So when you're talking about Robert Zubrin, for those who don't know, you're talking about an approach called Mars Direct, which is the whole plan that Zubrin laid out on the best way to go to Mars. And a lot of people, myself included, think that that's like the most efficient way, or at least it was as of the time that he wrote it. New technology and new knowledge about Mars, I think, changes it a lot. First off, ion drives. I honestly believe that we need a new form of propulsion if we're ever going to have a manned mission to Mars. It can't just be full point thrust. I mean, it's just, you do the math on how much fuel it takes, it's ridiculous, and the time it takes also. If you're using point thrust acceleration, you're pretty much limited to Hohmann transfer ellipses, which ultimately means it's going to take you 8.5 months to get to Mars, and then you have to hang out on Mars for like a year and a half, and then spend 8 months back, and you have no control over that. You're just stuck on that by the orbital trajectories. But if you have a constantly accelerating craft, then you can get them there much quicker, have them leave much earlier, and get home much faster. So that was one change I made to it. And also, I think in Mars Direct, I could be wrong, but I think in Mars Direct, his plan was to have the return ship on Mars, and then they lift off of Mars and just go home, whereas I leave a much larger ship in orbit, and the return ship just gets them back to that ship.
Yeah, and that felt like when I read that was definitely very different, and I thought that was genius, right? That's a way.
Well, it's just how Apollo did it. It's not like I'm the first person to think of it.
Yeah, no, for sure. Right, this idea of lowering a descent capsule and then using an already refueled spacecraft to come back. In fact, it almost felt like the need to make all that fuel, when you're really just trying to get back up into orbit and it's more about getting catching up with the Hermes as it's coming past Mars, because it's not going to be going slow as it moves.
Well, the original mission plan in the book was that Hermes was in Mars orbit, and so the MAV takes them up to Hermes, and then they leave orbit from Hermes, right? One thing I think is really cool now, this is like new information about Mars since I released the book, was that there's a hell of a lot more water on it than we thought. Like Curiosity, where they are, if you take a cubic meter of soil from the area where Curiosity is, there's about 35 liters of water in it. Which means originally in Mars Direct and also in The Martian, the assumption was that there wasn't enough hydrogen, that there was no useful hydrogen to be had, and you'd have to bring it. And for every kilogram of hydrogen you bring, you can make 13 kilograms of fuel. And so you go like, well, we only have to bring 1/13 of the fuel. That's good news. Well, it turns out that now there's tons of hydrogen there too. So literally all you need to do is send the fuel production plant, so to speak. Getting the water out of the dirt isn't necessarily easy, but yeah, it's really cool. It's like you're limited only by like your production equipment.
Yeah, no, that is fantastic. So I let me see if I got a couple more questions. I hate to do this, but I could just go on all day is the problem. So, okay, last question. So actually, Cecil Morgan asked, so no, the Venusian.
No Venusian, no.
No, no. But what about these new Cloud City blimps? You've been reading about
Yes,
this?
the Bespin approach.
Yeah. So
Um,
come on, you can just
no,
imagine the harrowing story of a person trying to survive in the cloud tops, jumping from balloon to balloon. Yeah, yeah.
Yeah, fun thing about Venus, if you're 50 kilometers off the surface, the atmospheric pressure is 1 atmosphere. The temperature is about 40 degrees Celsius, which is about 100 Fahrenheit. And so you could, if you had like a breather mask, if you had like a scuba mask and some goggles, you could just stand out on another planet and be comfortable with both the temperature and pressure.
Yeah, and air is a lifting gas. So
yeah,
you can make your balloons out of just breathable air.
Yeah, that's true.
So again, I'm telling you, this is it. This is your next story.
Venus is a crappy planet. It's terrible.
Oh. Are you saying that it would be difficult for a person to survive?
Yeah. Well,
I think that's right up Mark Watney's.
It would probably be
right
easier
on his resume.
It would probably be cheaper and easier to build a moon base than it would be to land somebody on Venus.
I'm just saying. This is it. This is your next story.
That was my next story.
All right. Well, let's move on. Let's move on to some of the other stories that broke this week. And of course, Andy, feel free to jump in and ask any questions or provide any of your context as we crank. We are going to crank. This is going to feel like the Weekly Space Hangout at light speed. You may like this. I'm not sure. First, Morgan, we were expecting the most dramatic rocket launch and landing in modern history, and it didn't happen yet.
Didn't happen on Tuesday, didn't happen today. Hopefully it'll happen tomorrow. They've been working through an issue on the Falcon 9 that's carrying cargo up to the space station where they had basically a valve that wasn't working right on the second stage. And because all of these launch windows are very, very short, they don't have any chance to sort of cycle it and fix it on the launch pad. They have to drain the fuel off and work on it. And so every time they hit any sort of little hiccup, they got to push it to another day. And of course, we always want to be 100% or as close to it as we can, confident in rockets before we launch them. But this is especially important this time because the Falcon 9 is carrying the cargo that was supposed to launch last year on the Antares rocket that failed back, I think, in November. And so these are equipment, supplies, etc., that they've been waiting for on the space station now for a couple of months. And we want to make sure that there's no issues in getting them there this time.
And of course, this is the mission where this is going to, the first stage is going to detach, land on a very small target in the middle of the ocean, and usher in a new era of human space exploration, right?
They're at least going to try. They're playing it pretty close to the chest, and I think Elon Musk, the SpaceX CEO, has suggested that they probably have less than, and perhaps even much less than, a 50-50 chance of successfully landing on their first go-around. But every time they do it, they iterate, they get a little bit new information, and they're certainly getting a lot closer.
And they're a little bit disadvantaged, right? That they're having to land on a barge in the middle of the Atlantic Ocean just to prove that this technology is safe. Once they've mastered the almost impossible task of landing a rocket on a barge in the middle of the ocean, they'll then be permitted to land this rocket back on solid land pretty close to where they took off.
Yeah,
So,
not only do you have the pitching and rolling of the ocean to deal with, but this landing pad that they're trying to do is only about the same size as the rocket itself. It's about 100 meters by 100 meters. When, in order to land at Cape Canaveral, they only need to land within a kilometer by kilometer area. And so if they can do this, they'll have no problem consistently landing back on land, and that's the ultimate goal.
So if people want to witness... Oh, go ahead, yeah?
Oh, I just had a question. Why are they making them land on the barge first? Is that's some prerequisite that the government's making them do, or it's just something they want to do?
I think it's a little bit of both. The Air Force told them that they could land at Cape Canaveral as soon as they could land in a square kilometer landing area. And in order to demonstrate that, of course, they still need to launch the rockets out over the ocean. And I think they think the easiest way to demonstrate that is to, rather than try to maneuver it back to some uninhabited place on Earth, is just to let it come down where it's going to come down in the ocean and put a landing pad underneath it. And they've always kind of strived to exceed whatever's necessary. Since they are sort of pioneering this from the commercial standpoint, they don't want to be seen as cutting corners or even just kind of doing the bare minimum to get by. And they've kind of trumpeted that from the get-go.
Awesome. All right, let's move on. As I said, we're going fast
Tomorrow
here.
morning, it's like 3:30 in the morning Eastern time.
That's what I was going to ask, yeah. And actually, that launch date has been coming earlier and earlier and earlier. Pretty soon, it's going to be nice evening for us here on the West Coast, as opposed to me having to set my alarm at 1 in the morning. So for the night sky, Dave Dickinson, people should be looking at Comet Lovejoy.
Yeah, there's actually two interesting things going on this weekend. The first thing is Comet Q2 Lovejoy is already reached naked eye visibility. Last night I was out looking here from northern Maine in about 10 below Fahrenheit, and I could actually see it. I would estimate it was just a little brighter than 4th magnitude. What I'm seeing on the Comet Observers database is 4.5, which is pretty good. In binoculars, it's really easy to pick out. I mean, if you can find Orion and Orion's belt and you go to the observers right about maybe 10 degrees and just sweep around with binoculars, you can see it. I couldn't see the tail, but you're seeing a lot of really awesome photos coming out right now of there's been a few tail disconnection events, which are always interesting to witness too, as it gets buffeted by the solar wind. But there's a few binocular comets this year, but this one actually brightened up ahead of schedule. We didn't realize until about early December that we were going to have a naked eye comet. When Terry Lovejoy down in Australia discovered it back in August, it was predicted to maybe make 7th or 6th magnitude in brightness, but this one brightened up ahead of schedule. And it's coming right up. It's going to cross the ecliptic. It just crossed into the constellation Taurus and across the galactic equator today. Earlier this week, it crossed the closest to Earth, about, I think it's 0.4 AUs from the Earth, moderate distance, but it's got a high orbital inclination, so the southern hemisphere got a good look at it. Now we're going to get a good look at it here over the next few weeks. It's going to go right up through Taurus, through the constellation Andromeda, near the Andromeda Galaxy, between the Andromeda Galaxy and the double cluster. And incidentally, this weekend, the full moon is now out of the way. Last weekend, we had the full moon to contend with to try to find this comet. Now that the moon is waning gibbous and going toward last quarter, it's you've got it right in the prime time evening skies, right around 8-9 p.m. It's up high in the southeast, so this is a really good time to get out there and see it. I've been watching every clear night.
Right. Now, of course, the universe owes us a comet because it screwed us last year on Ison. But this really, I don't think the universe is really putting its back into it. I think, I think this is a naked eye comet, but it's just a little blob. There's no visible tail.
Yeah, it's equivalent. It's naked eye in the sense that the Orion Nebula is naked eye. It doesn't, it looks like a little fuzzy blob, maybe under dark skies. You got to get away. Last night I had to get really out away from any street lights or anything to even see it. It's right on the edge. And when you say naked eye for a comet, usually for a star or something like that, 6 magnitude is a good limiting. A naked eye magnitude, but for comets you have, like with nebula, you have that brightness spread out over its surface area. So really right around 4th magnitude is your limiting magnitude for a naked eye comet like this, because you have that brightness but it's not condensed down to a point like a star. So it's spread out. So you have apparent magnitude, then you have surface magnitude to contend with, apparent surface magnitude brightness. So it's not a spectacular one, not like Hale-Bopp or Hyakutake or anything like that.
No, this is not acceptable.
We'll do a comet like that.
No, universe, try
the big bright one needs to come by.
I'm going to need, go back, try again. I need another Hale-Bopp or a Hyakutake. That's really what we were expecting.
They're out there.
All right. We'll wait for them. All right, let's move on. So, Brian Koberlein, word on the street is that a star is going to come really, really, really close to the solar system. Is this it? Is this Planet X? Is this Nemesis? Are we doomed?
No, we're not doomed. Really close in this case is about 8,000.
Oh, no.
Astronomy units, and just to give you an Eris,
8,000
100.
8,000 what? Your internet cut off there for a second, so we didn't hear the units.
8,000 astronomical units is the distance.
So what? Can you give me that in light years?
I can't, but I can say Eris is about 100 AU. So this is 80 times more distant than Eris.
Which is really far, but that's pretty close. And this isn't going to happen tomorrow, right? This is going to happen.
No, this is about 400,000 years from now, and the thing is, it is close on astronomical terms because it is very possibly within the range of the Oort cloud, and that's kind of the interesting aspect of it, is because it may, in fact, disrupt some of the Oort cloud objects and start flinging them in our direction.
I did the math just because I do that, and it's 0.12 light years.
There you go.
0.12 light years. There
So
you go.
like about 1/40th the distance between us and Alpha Centauri.
Yeah.
Which is pretty impressive.
Really
I mean, when we talk
close.
about the closest star to Earth, right, at Proxima Centauri at 4.26 light years.
Technically, the closest star to Earth is the sun. Eh.
Oh,
Yeah.
right. We got one of those in the show.
I'm just saying.
The one thing I would say that's impressive about this is being able to measure the velocities of stars with such precision and being able to calculate the influences to simulate how close they might actually come. We haven't really been able to do that until very recently, and so we knew that there were stars in close approach, but to be able to calculate this and say there are 14 stars over the next million years that are going to come within less than a light year is actually astronomically a pretty big success.
And so does this, I mean, if that's going to happen that often in a million years, I mean, how often does it happen in a billion years? They must have come a lot closer. So does this mean that stars come closer to the sun a lot more often than we were expecting?
Well, I don't know that we knew for sure how often they would come, and it's hard to tell. We don't have, other than trying to calculate the simulations, we don't have an idea what the rate would be. And close in this case means more than a light year, within a light year. But we don't really know. There's been some ideas that maybe the stars disrupting the Oort cloud is what causes periodic bombardments and causes, extinctions. There isn't a whole lot of evidence to say that. We don't have any patterns where we can say, look, this coincides with different impact ratios. But we knew that there were close pass-bys of stars. We know that just in general, and simulations have shown that. What's interesting about this is that it specifically shows us where they're coming.
All right. Well, let's move on. Ramin, you attended the AAS, and I know Nicole did as well. So you guys can just tag team back and forth and talk about the interesting results that you learned at the AAS. And for those who don't know what that word salad is, it's the American Astronomical Society's annual meeting. This year was held in Seattle, and it is a party.
Here's so yeah, we can just highlight some of the main results and can talk more if people are interested. Here's the program with the requisite Space Needle, of course, and I would say, let's see, some of the results that were really interesting were some final results from the Baryon Oscillation Spectroscopic Survey, or BOSS, which is part of the Sloan Digital Sky Survey 3. Sloan Digital Sky Survey has, well, in this iteration, has observed something like 1.5 million galaxies, 300,000 quasars. It's one of the main instigators of what people call big data astronomy and precision cosmology. They measured the cosmic distance scale down to 1% precision, which, as far as I know, had not been achieved before. So it's really impressive results. So they called them final results. They sort of showed some figures and plots, but I think they're, the papers aren't actually out yet. So I think they're a little bit behind schedule. But I'm guessing in a month or something, their final results will come out. But at least as far as we can tell, the results are consistent with those of the Planck telescope. I'm just looking at my pages of notes here, and it's consistent with a cold dark matter cosmology with a cosmological constant. So the universe is flat, as far as we know, or at least very, very, very close to flat.
Nicole, let's hear one from you.
So there was a lot of exoplanet news. I had one piece go up on Ars Technica, new place that I'm submitting things, about the ingredients for building an Earth-like planet. And I like to rail occasionally when everybody gets excited about exoplanet discoveries that it's Earth-like, it's Earth-like. It's like, no, all we know is the radius. We know nothing else about it. It is Earth-sized in radius. But this is a follow-up on some of these smaller exoplanets discovered by Kepler using HARPS, which is the High Accuracy Radio Velocity Planet Searcher. And that is actually measuring the masses of these really small exoplanets. So they looked at exoplanets smaller than 2.7 times the Earth's radius, got their accurate masses. One in particular, Kepler 93b, is 1.6 Earth radii, or circumference, diameter, whatever you want to use, not circumference, but diameter, and 4 times the mass of the Earth. That gives you a density that puts it on this model that says it has a very similar composition to that of Earth and Venus. So a lot of these, so it joins a group of these smaller exoplanets, these less than about 1.7, 1.6 Earth radii, as discovered by Kepler, showing that their masses agree with an Earth-like or Venus-like internal composition. So all these Earth-sized planets, these smaller Earth-sized planets, may really be Earth-like, at least in composition, after all. Of course, there's a whole host of other factors that go into it, like distance from its host star. That one in particular goes around some ridiculously tiny short orbit, so that wouldn't have liquid water on it. But at least in the interior-wise, it's very much like Earth.
That's awesome.
They actually came up with a cute little recipe, which I could share a picture of somewhere, of how to make an Earth-like planet.
Okay,
Right.
Venus is Earth-like, right? It's got the same radius.
Yeah,
So
I was
Mars.
just thinking that
Earth-like.
if we were looking at Venus from really far away, we'd be like, oh, that thing is the most Earth-like planet we've ever seen.
Yeah.
It's true.
It's
Let's
like
build an
fairly
interstellar-
far away. It's kind of in the range where there might be liquid water. Yeah, it's 500 degrees Celsius on the surface, day or night.
Yeah.
90 atmospheres of pressure. Yeah.
But can you imagine if like a person was trying to survive on the surface of Venus? Wouldn't that be tough?
No, it's not a good.
So hard.
Not a good book idea.
Just
Kepler had some artistic posters that were saying, like, visit Kepler 16, and it showed like a travel kind of promotion thing.
Yeah.
I think most of these alternative books could be summarized by the first sentence in his book.
yeah.
It's a one-line book.
We can't even say it.
family show.
All right. Well, I'm gonna go back to Morgan quickly. We're gonna talk about some super oceans on super Earths.
Yeah, so now that we've found thousands of exoplanets using Kepler and other methods, we're kind of bored with finding just normal exoplanets. That is so 1990s.
Yawn.
And now we're
7,000
interested, as Nicole was alluding to, in finding planets that look like the Earth, or at least ones that could be habitable, whether or not they actually look like our planet. And the one thing we know that we need here on Earth for life is water. And so the question is, are these planets that we're finding out there, these so-called super Earths, could they have water in them to the degree that we would need to sustain life? And the Earth has a lot of water, a lot more than you can see just on its ocean. There's actually way more water trapped within the Earth than there is in the oceans. And we're kind of in this equilibrium point where water is getting sucked down into the Earth by sort of slipping between the cracks in the tectonic plates and then being spewed back out onto the surface by volcanoes. And if you don't have enough volcanism, all your water gets sucked underneath. And if you don't have plate tectonics, you're not generating energy and sort of recycling that you need to create what we think of as healthy habitats for life. And so this was another presentation that came out of AAS, and they did a series of simulations on planets from the Earth size up to 5 times the size of the Earth in radius, and asked the question, would water exist on the surface? And it turns out that the answer is yes, that in fact some of these larger planets, 2 or 3 times the size of the Earth, are even more efficient at recycling this water out onto the surface. And we could expect enormous oceans to exist on many of these worlds. But it happens a little bit more slowly than it happened here on the Earth. Here on the Earth, we had water on the surface pretty quickly, within hundreds of millions of years of the formation of planet Earth. But on some of these larger ones, the simulation suggests that the oceans might not begin to form for, say, 1 billion years, but then they might last for 10 billion years. And the big takeaway is not talking about this planet or that planet, but the idea of where we should be looking if we want to look for planets where there might be signatures of life. And we'd want to look for planets that are older. These aren't the ones that are forming right around baby stars. We want to look for planets around stars that are, say, 2 or 3 or 4 billion years into their life, because that gives time for the water to to come out to the surface, and it gives time for evolution and life to generate something that might be interesting for us.
Right, and this is one of the concerns with these smaller red dwarf stars is that they last a long time, but the early parts of their history, they're very volatile, very dangerous to be around, and so you wouldn't want to try and be life evolving under the terrible blasts of a red dwarf star. But you know, who cares? Give it that billion years for it to settle down, and then your water is there, and now you've got a nice environment where you can be orbiting your red dwarf for 100 billion years.
Yeah, it's just one more constraint, basically, as we sort of try to narrow in the question, what makes a habitable planet? We had this temperature idea. We have this sort of rough density of the planet idea. Now we're adding basically one more little idea about what makes a planet that you might find life on. And this is how we're going to kind of attack this problem, is by chipping away at the definition from all sides until we've narrowed these thousands of exoplanets down into just one or two that we can intensely study.
Fantastic. All right. Dave Dickinson, if I am, I guess, feeling a little sad by how mediocre Comet Lovejoy is, what else could I see in the night sky?
There is a very good quasi-conjunction, might as well call it a conjunction, of, it's technically
Quasi-junction?
of Venus and Mercury low to the west. They've been approaching each other, and they're going to be about 38 arc minutes apart tomorrow evening. They're about a degree apart tonight. I got a good shot at them last night. The skies were clear, and I'll probably going to be taking another look with binoculars. So if you've never seen Mercury, which a lot of people never have because it doesn't ever stray far out of the twilight sky, tonight and tomorrow night and this weekend, if you got clear skies to the west, it's going to be a good time to try because you're going to have it very, very near Venus. It's going to be closer, well, right about as close as a full moon. A full moon is about 30 arc minutes. It's going to be a little further apart than a full moon in apparent separation. So if you've never seen Mercury before, this is a good time to kind of check it off your life list.
Right, so if you can find Venus, you can find Mercury.
And the reason we call it a quasi-conjunction, it's kind of technical. It's one of the reasons it didn't make it into my 2015 roundup, as Phil pointed out, is the fact that it never quite reaches, they never quite reach conjunction in right ascension. The program that I use to filter through for looking for bright planet, naked eye planets that are within 1 degree, it never caught that when I filtered them out last year. So, but I amended that by writing an entire article in Universe Today this week just about the quasi-conjunction. And what a quasi-conjunction is, we go a little bit more into, and I link back to Nicole's article on Mercury in retrograde because that plays into it as well on Skeptic. So,
is Mercury in retrograde right now?
It's going to be in retrograde. Mercury spends a lot of time in retrograde, so it's convenient to blame your earthly woes on. But
yeah,
you know,
absolutely.
It always seems to be in retrograde.
Yeah,
so.
Right. All right. I don't know if Brian, if you can do this quickly. There's a new image of Andromeda.
Yeah, there's a new high image of Andromeda. It is, I think, 1.5 billion pixels. So it's so huge most computers can't even see it. So you have to kind of go to the NASA site and use the zoom tool to see this. But it shows about 100 million stars in the Andromeda galaxy. Now Andromeda actually has about 1 trillion stars, so this is only one small fraction of them. But if you haven't checked it out, check it out. The resolution is just jaw-dropping. It's incredible that we can see a galaxy in this detail. You know, with that imaging, it's incredible.
Yeah, the full file I think is 4.3 gigabytes.
Yeah.
Wow.
Right.
Yeah.
So
that's just the processed image file.
Yeah, and so of course that's you know, how does a person download a 4.3 and do anything with it? So yeah, they've got this great viewer on NASA's website where you can go and like zoom in and zoom out, and so you're seeing 100 million stars in this image, individual stars that you can pick them out.
Right, and you can find star clusters. You can find nebulae. You can see nebulae within other, you know, the Andromeda galaxy, which is just kind of amazing. Wow.
Yeah. So you just have to take a look at this picture.
Yeah.
And the people who took it have a great acronym too. It's PHAT, P-H-A-T,
yeah.
Panchromatic Hubble Andromeda Treasury.
So I got a question from Elad Avron about this. Do astronomers come up with the acronyms first, and then the actual words that make them later, or do they go the other way around?
Yes.
Sometimes, yeah.
If we can make a joke, we will.
So yeah, they do both. And when I was at the University of Virginia, they would often email the whole department and say, "We're trying to think of an acronym for this instrument. Submit your best ideas." And like everyone would submit their funny, ridiculous ideas, and they'd pick out of that.
And so they would have to both work as a technical scientific term and also an in-joke about this.
Yep.
Yeah.
Pretty much.
Yeah. All right. So just in case you thought this was the case,
they're pretty tortured.
It is the case. Yeah. All right. All right. We got time for like just a quick anecdote from AAS. So Ramin, I'll give you one more interesting thing that you saw at AAS.
Well, I guess I'll end with there was a great talk about the Planck telescope by Martin White. He described the telescope as having the height of a small giraffe and the weight of a heavy hippo. And he showed results that weren't that different from what we've talked about before on Weekly Space Hangouts. As far as I know, the BICEP2 Planck joint result still isn't out yet, but it's going to come out in the coming weeks. So basically, he just hinted at those tantalizing results, and I think we'll have to wait a little bit more, but we'll watch out for that.
You tried all of your wiles to get the answer out of him?
Well, he'd probably get in a lot of trouble if he announced to me, let alone to thousands of people, what it was.
Interesting.
But I got to teach you how to do this later on. You're like, come on. Come on. Come on.
Thank you for the information, Professor or Doctor, and I understand you need to keep things quiet, but come on.
Come on.
Come on.
I'll work on that.
Did you see primordial gravitational waves or not? Come on. So, all right. Nicole, do you have an interesting thing that you saw at AAS?
I met Ramin.
Another meeting for the first time in person.
I've got a couple of drafts up for working on for Universe Today, actually. You guys had all the press release stuff down, so I'm working on some of the things that were either plenary or some interesting science, some interesting radio astronomy science that was announced not in the press releases. So I'll be finishing those up. You can look for them
right.
today.
You had your press hat on with the little Universe Today badge.
I had like press on one side and job hunting on the other side, so I just kept flipping back and forth.
Depending on who you were talking to. Terrific. Okay, well we've reached the end of our hour, and I know that Andy's got a lot of more writing to do. I can see his brain already working. God, how will Andy? I recommend you look into Stirling engines for using a Stirling engine as a way to create a rover that can last a long time on the surface of Venus. I'm just saying, just take a look. But so where do we find out more about Andy Weir?
Well, Googling me will get you to the websites that matter. I have a website where I put my fiction, but it's a long URL that nobody will spell correctly. So just Google Andy Weir writing and you'll find it.
And like you write one paragraph, and then some book publisher comes in and scoops it up and makes it disappear again.
Oh, no. I've got a lot of short stories up on that site. It's quite a backlog that people could read if they wanted. So. Yeah.
And people also follow you on the Facebooks, right?
Yeah, on Facebook, you can follow me there.
And no Twitter feed.
No Twitter feed. I'm sorry. I guess I'm just that. I'm 42, so I'm in that generation where I was like, I'm a little too old for Twitter, too young. Wait, no. Too old for Twitter. too young for like MySpace.
Oh my God.
We're too old for Twitter too.
Yeah.
So.
Yeah.
Snapchat.
Don't worry, it took us a long time to get Fraser to use Twitter, so you're fine.
It would just be this barren wasteland. It would be like, hey guys, it's my Twitter account. And then like a month later, it would be like, test. And then like...
Anyone listening?
Yeah. Popularity, dude.
Yeah. I just had this for lunch. Yeah. No, we'll get you hooked up. We'll get you hooked up. Brian Koberlein, where do we find out more?
You can find me on Twitter, even though I am over 40.
You're just so
you can
much
find
more
me on Twitter. Yeah, well, at Brian Koberlein. You can find me on my website, briankoberlein.com. I blog there. I blog on Google+, if you hang out there. Those are kind of the big places. So.
Awesome. Dave Dickinson, now that we've been able to tie you down, where do we...
I should be stationary for the next month. should be stationary for the next month or two, and I'm active on Canada.com, Listasaur, Universe Today, of course, my own site, AstroGuys with a Z, and I will be out tomorrow morning watching for the ISS pass and hopefully the SpaceX CRS-5 mission following behind it after it passes. After it launches, it should come right up the East Coast, so I'll be out there with binoculars.
Awesome. Morgan.
Yeah, well, you can find me right after this, as always, over in the Google Plus Space community, where I can take any questions that we didn't get a chance to get to today. There was lots of stories over the last month that we couldn't talk about. If you want to know how I would survive on the surface of Venus, I can help you out there as well.
That'll be a short broadcast.
Or you can tweet at me at Morgan Rehnberg on Twitter, or see my blog at cosmicchatter.org.
Fantastic. Nicole.
Hi, I'm Noisy Astronomer. I'm still hanging around at SIUE for one more semester. And yeah, you can find me at noisyastronomer.com. I will still be helping out the CosmoQuest team a bit, so cosmoquest.org. What else am I doing? And I'm writing with Ars Technica and have some great stuff coming up on Universe Today.
Fantastic. Ramin.
You can find me on Twitter at Ramin Skibba, and then I blog about astronomy news and science policy issues at raminskibba.net. And I plan to write one or two things for Universe Today about some nice results at the AAS meeting too, including about those BOSS results. So watch for that.
Those BOSS results. That just sounds so good.
You do BOSS, I'll do
the BOSS.
Apex. You've got all the Sloan covered.
Yeah, awesome. And and I am, of course, Fraser Cain, publisher of Universe Today. You can check out our YouTube channel. We just posted still more videos. We're going to be shooting a bunch more videos tomorrow. So some really cool topics.
How do you have so many ideas?
I don't know. I just do. Dude, I've been doing this for a long time.
For like 7+ years. They just never. Fraser's head just makes things.
Yeah. But you can of course follow me on Twitter. I can show you an example of an old man learning a new trick. This is my Twitter feed. So F Cain, and we will see all of you next week. And of course, a huge thank you to Andy Weir for joining us. It was an absolute honor and a thrill to have you join us. It is a great, both the story, the book itself. I am absolutely not kidding. If you buy this book and you didn't enjoy it, I will give you a refund. And I will grab that book and I will hand it off to someone who is more deserving. And also just the most amazing story just to show how you sort of found your way into being such a successful author, and I can't wait to see what you do next. So anytime you want to come and join us, feel free. The hatch is always open and pressurized. So.
Well, thanks. Thanks so much for having me. And Morgan, I see Resistance and Through the Ages in the background there. I see that.
Indeed.
up on the shelf. I can't read the text, but I recognize the boxes.
Yeah.
So I see a fellow board gamer there.
That's right.
Yeah, I think he's got a copy of Dominion back there too.
Oh, I take magic card holder, like the books that hold magic cards, and I have all the little.
There's so many.
Cards. Yeah.
Okay. All right. Well, I'm going to regale a one quick anecdote, which is I used to write for Wizards of the Coast, which is the people who came up with magic cards, and I traveled to Gen Con one year with the folks from Wizards of the Coast, and back when they did, this is 22 years ago, they demoed this new card game that they were making called Magic, and they had photocopied pictures on the cards, and I learned how to play Magic with Richard Garfield. So it was, yeah, I take all your nerdery and take it to the next notch.
The nerdery.
So, yeah. All right. Well, hey, we got to wrap this up. Thanks everyone for watching. Thanks everyone for joining us this week. We really appreciate it. And join us next week when I don't have a guest planned, but maybe if you like this, we'll try to have one planned. So yeah, we got all these great people. Yeah. Come for them. All right. We'll see you all next week.
Bye-bye, guys. Thank you.
Bye.